All right, so today we're going to talk about recursion. Recursion is when a method calls itself. This might sound like a bad idea, like an infinite loop. So if the coin flipping program called itself, then it would flip forever. Even longer than if we just did it with integer.max value. Actually, Java figures out that's what's happening and says, sorry, infinite loop, Stack Overflow, you've crashed or something. So, okay, it sounds like a bad idea maybe to be in a loop like that, but there are many interesting problems in computer science that can be solved rather elegantly with a recursion solution. So there are many programming tasks that can be better solved using recursion. That said, any recursive problem can be done with regular loops. They say. A recursive method has two properties. One, a base case, some way to exit the loop. And two, a call to itself. And I'll show you some examples. One thing, recursion tends to be, I don't want to psych you out ahead of time. It's not that bad, but it does tend to be a little scary, a little confusing. Good news, AP test, you won't ever have to write a recursive method. You'll have to, on the multiple choice part of the test, you'll be shown a method and it might say, how many times does this code execute before it ends? Or what's the status of this variable after this code is run 3 times through the recursion? You'll see, because we'll do practice problems on the AP Classroom. But they won't make you write a recursive method on the AP test. All right, let's go to...
We have questions like when we pick up pretty easy there. What does this print?
They have ways of making it not easy, but yeah, some of them are pretty straightforward.
Where do we go on AP test? Do we go to like a big room?
The big room that is called the library. Yeah. So we've got I've made a recursive method right here. It's called Factorial. Have you all used a factorial before? Most of you have. Factorial is when you multiply a number by every number under it down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. 100 factorial is a big number. So look at this function here, or this method. Public static int factorial. So you send it a number, and here's the base case. It says, hey, if the number is 0, return 1. Otherwise, return the current number times the factorial of one less number. So when I call factorial 5, it n isn't 0. So it calls 5, it says return 5 times factorial 4. Meanwhile, it kind of holds that result over on the side. And then it calls factorial 4. And then when it gets to 4, it says, okay, well, this is 4 times factorial 3. And then it goes to 3, and then it goes to 2. And then finally, when it gets down to 0, instead of looping forever. It just returns the number 1. So in the end, when we make this call, we're going to get 5 times 4 times 3 times 2 times 1, which is 120. So 5 times 4 times 3 times 2, and the times 1 is just a given. Yasha?
Can we do the factorial integer max value?
You know what? You can't even do 50.
Oh, really? Okay.
I forget what happens, but it just blows up. It's too big. That's you in 1 minute. I haven't figured out where it breaks, but I think even 10 might be too big. But that's because we're using the integer variables, and integers have a cap at how big they can get.
So if we had like a long or a double, we could do it bigger.
You could do bigger if you used a long or a double. So I did factorial 15, and I think we're close. I think it might just be broken. Yes, remember it rolls around and becomes a negative number. So anyway, that's not related to recursion, though. So again, I'll show you the function. You should write this down because you're going to have to write recursive methods in about 5 minutes. So it'd help you to have some examples in your notes. So I labeled the base case there. Somehow you have to have some way for the thing to know when it's time to end. You guys got this? I'm ready. I'm sorry, you'll have to get it later. Do you guys know the Fibonacci sequence of numbers? So on the next method, since some of you didn't manage to write it down, let's write it down right away rather than wait until I've talked about it for 5 minutes and then start writing it down. Fibonacci sequence, there's different ways to start it, but the way I'm starting it is the first number is 1, and the second number is 1, and from then on, you determine the next number by adding the 2 previous numbers. So 1 plus 1 is 2, and to get the next number, we go 2 plus 1, the previous 2 numbers. So we put a 3, and to get the next one, it's 3 plus 2 is 5, and 5 plus 3 is 8. Okay, so I made a recursive function called Fibonacci that gives us the nth number in the sequence. So if I send over a 1, we should get a 1. And if I send over a 2, we should get another 1. And if I send over a 3, we should get a 2. 1 plus 1 equals 2. And so, in fact, I've got a nice way to do this. I'll just do a for loop. Bless you. We're going to go ahead and do just the first 10 Fibonacci numbers. And I'm going to print them on one line with a space between them. And then I'll show you the method. Just wanted to show you that it's working. So here's the first 10 Fibonacci numbers. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. So then to look at the code, it's a very simple. Now would be a good time to write it down. I've got a base case. It's kind of a double base case. If n is 1 or n is 2, then we're just going to return 1. Right? If it's the first term or the second term, just send a 1 back. Otherwise, return the previous 2 Fibonacci numbers added together. Boom. It's not that bad. And I know what you're saying to yourself. What would happen if we said Fibonacci max integer max value? It would take a while.
Well, Fibonacci mean value.
That's a negative number. I don't know. My code doesn't handle a negative number, so. So those are two common recursive functions. Recursive methods. The next one, and I promise you these get more applicable to like real things that we're going to want to do, but this one, instead of doing a return, it just prints stuff. And you send over a number, and it's going to print that number and then go down by 2 and print the number over and over and over again until it gets, as long as it's greater than 2, it keeps going down. So it would go 10, 8, 6, 4, 2, you know, kind of counting by 2s backwards. I think you should, yeah. And I'll even make it show again. This one is called down by 2, I think. Was it plural? It is plural. Down by 2s. So this one, you just call it with a number. There's no, I don't have to print anything. But here I said down by 2s. I send over 20, and it goes 20, 18, 16, 14, 12, 10, down. So this has a base case. I didn't label it, but it's right here. If n is greater than 2, it's kind of a reverse base case. This is just testing, hey, if n's bigger than 2, then keep calling this function. But notice each time it calls it with one number, 2 numbers less. Thanks. Questions? All right, so I made one more function to show you today. It's up by 2s. And you think this is going to work just the same way, but I want you to notice the difference between these two. I put the print after the recursive call. So this is important. Different things will happen. But let's walk through the top one first. Down by 2s. You send over 20. It prints a 20. Then it calls itself again. Now it's been called with 18. It prints the 18, and so on. And they come out like this. Now, when we do the other one, over here, notice the print call is after the recursive call. So what happens is actually it prints out in the opposite order that you might think. It's going to be, look, I'm still calling n minus 2 here. But, so I'm calling it, we get 20, and then I'm calling with 18, 16, 14. But it's going to print it out in completely the opposite direction. So I'm going to, I'll show you what I mean. And the reason it does that is because the print call is after, it's after the recursive call. And so Java just sets that stuff aside. There's actually this thing called the stack, but you don't have to really understand it, and I don't really understand it completely. Java's going to, when you call this function with 20, it says, oh, hey, I'm greater than 2. I better call it with 18. And I better call it with 16 and 14, all the way down till it stops calling it. And then it starts printing all these things that it saved up. So it's going to print the 2, 4, 6, 8, all the way back up to 20. So that difference in functionality we achieve by just moving this here. So when the print line is before the recursion call, it's kind of straight ahead, does it in the order you think. When the print line is after the recursive call, the output is all backwards. It kind of goes in the reverse order. So when you're trying to trace one of these problems, you want to keep track of where the print is. Is it if there's a print, is it before the recursive call or after? And you'll through experimentation get used to it. All right, so I'm going to post our